Thank you, Jean. I will confess I was a little afraid when I was told Jean was going to introduce me. So before we get started, I do want to make a very hard declaration for both our in-person and our recording audience. This is an absolute spoiler zone. Okay, there is no way to have this conversation without drawing on information from the original 3 books as well as Times Convert. So brace yourselves. So one of the things that we see in the progression of the book, especially the first 3, is we see multiple de Clermont men with blood rage. But we see it in very different ways. So initially, it appears that with Matthew, it's only when he's very, very angry that blood rage manifests. We do find out in the Book of Life that any very strong emotion brings it out in him, but he is much more capable of controlling it with the love, if you will. He is able to let Diana go away from him for a time. He is able to manage his symptoms. Jack especially, first spoiler, Jack, especially in the Book of Life, is almost incapable of controlling his immediate blood rage response in the presence of strong emotion, including his love for Diana when they reconnect in modern times. Before we get into that and the possible explanation for those differences, we do need to do a little bit of biology. For those of you who have seen me before, you know I have to do this. So. First off, and this comes up a bit in the book, we have a discussion of different types of understanding and our growing understanding of biology and inheritance, and especially genetics. So originally, we have what is now known as classical Mendelian genetics. This is what the monk Gregor Mendel developed as a result of his experiments in the kitchen garden at the monastery, in which we ultimately reached an understanding of one gene, one trait. Okay, so this is the very classic white is recessive compared to black. And there are traits that do abide by those simple rules, but not very many. As we begin to look at the world around us, and you can see this as you look around the room, we have a lot of traits that are very complex. So think about skin tone in humans. Think about hair color, even think about eye color. They are very complex. There's a whole range that you can get. Human height is another example. There are multiple reasons why you can have what we now call a non-Mendelian trait. It could be it's a pleiotropic characteristic. That means one gene is impacting multiple traits. We have some of that if we look at the genes, for example, that conveys the disease we know as sickle cell. That's a pleiotropic gene. We also have polygenic traits. That's when you have multiple genes impacting a single characteristic, such as height and skin color. We have sex-linked traits. And I will confess, if it were not for Louisa, it would be easy to believe that blood rage is sex-linked, but it's not, because we do know that Louisa, Matthew's sister, had it. Now, of course that shifted. Just a little bit on evolution, because evolution is absolutely at the heart of the trilogy. What is happening with creatures? How did the original human species devolve into these 4 different co-localized, overlapping groups, if you will? So evolution is based off inherited characteristics. It has to be something that's controlled by genes, because that is what's passed on to the next generation. A very important thing to remember, evolution is situationally dependent. Okay, so what is of advantage in one environment may not be of advantage when you move to a different environment or when your environment shifts. Skin color is a great example of that. It is advantageous to have darker skin if you live near the equator because of the exposure to solar radiation. It is of advantage to have lighter colored skin if you live near one of the poles so that you can maximize your sun exposure and production of vitamin D. Situationally dependent, what you need where. Again, as the environment changes, so does what are considered positive characteristics or positive adaptations. And these individuals, this is Charles Darwin, which we probably all have heard of. This is Alfred Wallace, who actually helped come up with what we now know of as the theory of evolution, but is not generally acknowledged. When Darwin was developing his ideas, he did read the work of another gentleman, Lamarck. And Lamarck had developed an earlier hypothesis in which he believed acquired traits could be passed on to offspring. So for example, if you go out and you get a dark tan and then you have a child, your child would have darker skin because of your tan, not because of your genetics. Okay? So again, remember, when Mendel and Darwin were both developing their ideas, which they were almost contemporaries, they didn't know about genes. We had no idea what controlled all of this. So this at the time appeared to be a logical explanation because you could look and see, okay, the tallest giraffe gets the most leaves, or the strongest monkey is able to beat up the others, that kind of thing. So perhaps if you work on and build up a characteristic in the environment, that will be passed on to your children. This was quickly debunked once Darwin's ideas were really fleshed out, especially once we began to understand what genes are. But interestingly, we're going to come back to Lamarck and environmental impacts. So, Chris in the Book of Life reminds us very pointedly that vampires, witches, demons cannot be subject to a traditional Mendelian understanding, especially in the case of vampires. Okay, there are the two human parents, and then you're going to have the vampire sire. So already we're in a three-parental situation that really messes up our understanding of genetics as far as humans are concerned. Chris is not wrong, okay? And this is really what we see fleshed out in the Book of Life, okay? Even simple humans with our, regular number of chromosomes, not with any creature chromosomes, very rarely do we have simple genetics. As I said, there are absolutely traits that are controlled by simple genetics, if you will, but we also know there are environmental impacts, okay? Environmental impacts can become genetically inherited. So for example, if a lineage is exposed to nuclear radiation, that causes a lot of mutations. If it's exposed early enough in development, the mutations occur in the reproductive cells. Those mutations will then be passed along. That's a relatively obvious one. Okay, that's a lot of what we see. Some television channel did the Chernobyl series recently. That's a lot of what's going on with the ongoing work in Chernobyl, seeing the long-term impacts of that nuclear fallout on genetics in organisms. We also see traits in which we know it is a combination of environmental impacts and genetics. So since we are a predominantly double X audience in here, we do have the bursa genes. These impact likelihood of developing breast and ovarian cancer. Having one of these genes doesn't guarantee that you get those cancers. It does give you a higher likelihood of getting it, which then must be taken into consideration when considering your environmental exposures and lifestyles. So what we want to do is we want to think about simple genetics, if you will, and environmental impacts together. And that takes us to the idea of epigenetics, okay? Epigenetics is the heritability of acquired traits. So we are going back to our dear friend Lamarck, and we are beginning to find evidence that, in fact, exposures that parents have as adults has impacts on their DNA without mutating the DNA itself, and those are able to be passed along to children, okay? I'm going to just skip, oh, no, sorry, I thought I had another graphic. These are some of the different mechanisms. If you are interested in any of the three top bullets, please do find me afterwards. I will not subject everyone to those conversations otherwise. But the important thing to keep in mind, what we are talking about basically as you go through life, even if you're not exposed to some really harsh environmental conditions, your body does things to control genes that are expressed at different times, okay? You need maybe more oxygen because you're a marathon runner. your body begins to make changes in how your DNA is expressed, which means the proteins that are produced. And it does it by adding little chemical tags. Traditionally, we thought that when cells are produced for reproduction, all of those chemical tags are stripped off and it's a blank slate. But what epigenetics is telling us is that that's not the case, that in fact some of those tags do carry into the next generation, and therefore they automatically impact traits outside of traditional DNA mutations. You're not really here to hear me babble about science, I do understand that. So let's talk about our blood rage and the de Clermont-Man. I am so ridiculously pleased with this graphic. So I took our published books, first three and Times Convert, and I created the pedigree of blood rage as we know it right now. Now, right down here, and this is very understandable given our cast panel yesterday, Marcus has a hell of a lot of children, okay? A lot. So before any eagle eyes start saying, what about Vanderslice, what about X, Y, and Z, I didn't have a choice but to restrict Marcus's brood because it wouldn't have fit on the slide. So these are just Marcus's children who are named in New Orleans. Two other interesting things about pedigree. So up here, I chose to use the red square to indicate blood rage. Okay, we knew Isabeau's maker had it. That's how it gets in the lineage. We know Matthew has it. We know Louisa had it. We know Benjamin, Jack. Molly was the only one of Marcus's children that I was reasonably confident saying had blood rage because she is the first that is killed when Matthew and Louisa show up in New Orleans. The other thing, if you see a sliced line in traditional pedigree drawings, that means an individual is dead. We don't actually know how many of Marcus's children are killed. We do know Matthew gives his accounting to ransom, but they're not named. These individuals are absolutely named in Times Convert as being killed, so I felt confident in marking them as dead, but there's no way to indicate unknown life status in a pedigree. In traditional genetics, you pretty much know if your subjects are alive or dead, so that's what we've got here. But let's look, what we're going to be talking about, again, is we're going to be talking about Matthew versus Jack's blood rage, and also Benjamin's. Okay, so this is the lineage we're discussing right now, and here's the spoiler, by the way. Father Hubbard does not have blood rage, remember that. That's Jack's sire, Benjamin's son, no blood rage. Marcus does not have blood rage, but we do know that it showed up in his lineage, especially in New Orleans. That's where it's called out specifically. Again, Molly being the only one I was confident with. The others, I'm not certain. And that includes the ones that are called out by name as being killed, because Matthew tells us in the Book of Life when he's talking to Ransom, I saved who I could, but he was told to kill the entire lineage, so we have to presume he may have killed non-blood rage vampires. So what are we talking about? How do we get that difference between Matthew, Benjamin, and Jack? Well, first off, let's talk about whether or not blood rage can be a simple genetics. Okay, I mentioned Huntington's disease in my talk last year as an example of how you can see differing severity in a disease that can be explained by pure genetics. Okay, so in Huntington's disease, we have a fairly long gene, single gene disorder causes Huntington's disease. There are normally anywhere from 10 to 35 repeats of these three nucleotides. It's a CAG repeat. You don't need to know what those letters are. They just get repeated over and over again. CAG, 10 to 35 times. Across this room, assuming none of us have Huntington's, we're going to have a mixture of 10 to 35 of those repeats. When you cross into 36, you may or may not present symptoms, and that takes you up to 39. If you have more than 40 of those repeats in a row, almost always you have Huntington's disease. What becomes interesting is as the repeats go up, it changes the age at which you manifest and present the disease. So adult onset is anywhere from 40 to 50. The juvenile form shows up if there are more than 60. Getting back to that idea of how do we skip Father Hubbard, how do we skip Marcus? You have 27 to 35, okay, so we're getting to the high end. You're at risk for passing the trait along to your children, and they develop Huntington's disease, whereas you did not have it. So maybe, okay, this would explain Marcus and Father Hubbard being skipped, but then each giving rise to blood rage children. All right, we got to go back to what Chris said, though. We are not talking simple Mendelian genetics here. We know that's not the case. We've got the 3-parent issue at the very least. We also know that we are seeing the disorder manifest with different levels of severity. So, what do we need to think about? We can start thinking about what Marcus says and what comes out in the Book of Life, and that is that blood rage is related to regulatory regions, that quote-unquote junk DNA that we don't call junk DNA in science anymore. What he's talking about, I just wanted to show this graphic. So this blue region right here is going to be the gene that we're talking about. Upstream or downstream, they're going to be regulatory regions. Turn it on a lot, turn it off kind of things. This is what they mean by non-coding regulatory sequences. Maybe something about blood rage turns on a particular vampire trait at a super duper level, and that's why you get blood rage. Maybe something about Marcus's regulatory region keeps it off instead. It doesn't just have to be you get it if you have it in a bad way. It could be something about Marcus and Father Hubbard are different so that they don't manifest it. That's a possibility. But that does get us to just the presence or absence of blood rage connected to the regulatory regions as we learn from the science studies in the Book of Life. This is just an example to show you. I love to do this. Deb is an amazing, amazing woman. I have said before, I will continue to say there is no way that I could do nearly as good with history that she does with science. So there absolutely are human disorders connected to regulatory regions in this junk DNA. So perfectly valid explanation for what we see in the Book of Life. But I want to take it back to that environmental concern. Imprinting disorders are epigenetic diseases in humans. Prader-William and Engelmann syndromes are the classic examples that you learn about if you ever take a human genetics class. In both cases, Prader-Willi and Engelmann, it's one gene is mutated. If the mutation comes from the father, you have Prader-Willi. If the mutation comes from the mother, you have Engelmann. Very different manifestations, very different disorders, single gene issue. How does a cell know? Did it come from the mother or the father? The cell knows if it came from mother or father based off those chemical tags that get put on genes over the life of an individual. So the tags are recognized as coming from the father, or the tags are recognized as coming from the mother. This was the first indication that scientists had that those tags aren't stripped off during reproduction like we thought, that they can persist into the next generation. Now let's get to where things get really interesting, and perhaps, in my opinion, gets us to the key difference between Benjamin and Jack especially. There is growing evidence that the environmental conditions that an individual experiences during their life will be passed on in a way that we did not expect. So if we look back at Prader-Willi and Engelmann, this is a mutation, okay? This is a DNA change. So that is kind of an unacceptable way, okay, we can understand that. DNA mutations are what cause disorders. It was the imprinting part that kind of threw us for a loop. What we did not expect is these studies, which are becoming more and more prevalent, and that is showing that the experience of a famine while a woman is pregnant will absolutely impact the health of the child years later, including a higher prevalence of obesity and diabetes, things that are associated with metabolic disorders in adult based off your own life, not your mother's life. We also see transgenerational effects. So what does this mean? This means if your grandmother, for example, experienced a famine, multiple generations later we see these same impacts, tying back not to the metabolic state of the individual with the disorder, but multiple generations back. Okay, so we are seeing environmental impacts. We are seeing the heritability of acquired traits. It doesn't stop with metabolism. Metabolism is almost a little easier to understand. I mean, we know your diet influences your health long term. We know it influences obesity. We can all kind of wrap our heads around that and say, okay, well, it would make sense if during fetal development you didn't have enough food as a fetus that it would impact you metabolically later on. What we are also seeing is growing evidence that these methylation patterns, these imprinting patterns, which do come about because of exposure of the parent, then begin to show up in what are typically considered psychiatric disorders in the children. Okay? What am I talking about? Let's focus right here on the stress response. Okay, there is direct evidence that a parent, especially a father, experiencing a lot of stress in his life will give rise to children who have abnormal responses to stress. Everybody just put the pieces together? So what do we have? We have Matthew having made Benjamin in the midst of a war and abandoning him to punish him. We'll all concede Benjamin is, I think as Chris says, is batshit crazy. Okay, I'm not disputing that. But think about what he was exposed to. Think about what led, at least partially, to him being that way. I mean, he got whatever the triggers were for blood rage from the genetics Matthew passed on to him, but then he was exposed to an extremely stressful environment. He changes Father Hubbard. Okay, Father Hubbard was also, he's an interesting one. It's a stressful time. We'll leave it at that. But maybe he didn't have the foundational genetics for that stress to trigger. Okay, he didn't receive enough of the regulatory regions. He didn't have enough of the Huntington's-like repeats in his DNA to get the blood rage. But he has Jack. Jack is an extreme case of blood rage. Jack is a perfect example of this transgenerational impact. All right, so why? All right, let's throw aside, we don't really need to understand why we don't really need to understand how blood rage is inherited. The bigger question becomes, why is it even around? Okay, what does it do? Why would it persist generation after generation? Well, we need to think about that situational dependency that I mentioned earlier when we talked about evolution. What is a blood rage vampire? It's basically a really, really vampire-y vampire, right? What's a weaver? That's a really, really witchy witch, okay? At some point in time, they needed that oomph to survive, okay? Think about what a blood rage vampire probably does better than other vampires. What does Matthew do better than the rest of the Declaremonts? He kills people, okay? If you're not just killing people to kill people, or because you were told to kill people, why do you kill people when you're a vampire? You kill people to eat. You eat to survive. Again, validating this in humans, the human condition. We have sickle cell anemia. You have potentially heard of sickle cell anemia. You know it is a disorder in which the hemoglobin gene is mutated so that it does not carry hemoglobin properly. If you are infected, it is a recessive disorder, so very few individuals are affected. If you are affected, it's a pretty extreme disease. Has a lot of negative impacts. We won't necessarily go into those, but the question is, why do we still have it? Why is it persisting in the human population? Sickle cell anemia is a bad disease. It does not help you. What about these guys right here who are carriers? If you look at the overlap between the sickle cell trait and the occurrence of malaria, we figure out why it's still there. Having one mutated copy or being a carrier will impact a few of the hemoglobin cells. It will change the shape of a few of them. It is enough to help these individuals survive a malaria infection. Okay? And so if we look at the persistence of sickle cell anemia and persistence of those genes in most human population, we do see that that was an advantage, okay? Back in the day, and by back in the day, I mean early stages of human evolution in these areas, you know, hundreds of years ago, a couple thousands of years ago, you got malaria, you were going to die, okay? You get sickle cell anemia, you're going to die. You're a carrier, you might survive, okay? And so you survive and you pass it on. You survive both the malaria and you survive the few sickle cell characteristics that you receive. All right, so what are we doing? Let's tie it all back together. You guys are already light years ahead. You jumped to, you know, blood rage, vampires are really vampire-y, but we do know it's connected to non-coding region. That's what the Book of Life tells us. It is likely, given the difference that we see, again, between Matthew, Benjamin, and Jack especially, that is connected to environmental exposures, and that gets us into that epigenetic inheritance, especially that transgenerational impact. And also, I'm not convinced that parent of origin might not be impacting it. So it might be similar, not just to the transgenerational effect, but it might be impacted by the fact our more extreme blood rage cases are in male vampires. What I really need to find out from Deb is if Matthew has any daughters and whether or not they have it. So, all right? And that's it. Plenty of time for questions. Oh, we are starting in the back. And I don't have a whiteboard this year, so we do not want to see me freehanding on the computer. So please, no whiteboard questions.
Hello. I was wondering if you ever considered the person themselves, because it was said in Book of Life that Matthew, as a human, might have been demon. Do you think that that demon DNA might have been the sort of the oomph, really, to make them who they were, sort of like a hypersensitivity? Because Jack, as a child, was an artist, and Diana was said to have part demon as well. So do you think that that would have made them her the weaver, sort of the intellectual part, the artistic part, that would have given them that sort of that extra level, and not just sort of, instead of sort of passing it on, would that sort of extra layer have made them really who they were? So it's more of an individual as well as a sort of a...
Yes, so I absolutely do. I think that gets to Chris's point of vampires have 3 parents. And so if we think about it, we're going to have to smash all these ideas together. But that piece of it, you can think about like the Huntington. If an individual already has extra of those demon regions, those regulatory regions floating around in their human chromosomes, when they then get that influx of whatever it is from a vampire parent that draws those together to make a creature chromosome, then it probably does push them that much closer to it.
One of the thoughts of people who've got dyslexia, that if their parents got it and their grandparents, they've got a higher chance of becoming dyslexic. I mean, in my family, both great-grandparents, grandparents, and my parents are both severely dyslexic, and all 4 of us have some form of dyslexia.
So that's possible. There's a lot that we're still trying to figure out about disorders that we have not previously attributed to a genetic cause, but that just may mean that we haven't found it yet. So I do think it's likely. I also think it's likely that that may have, for a very long time, been an undiagnosed condition, and the fact that you have it makes, or a person has it, makes them more sensitive to the signs, the earlier signs in their children. We see a little bit of that in the trilogy, actually, if you think about Agatha and Nathan. She recognizes right away that he is going to be a demon, and she is able to kind of guide him through that, versus you have Hamish and his demon mentor, if you will, relaying the story of how, you know, oftentimes it shows up just in a human lineage, and so the signs go unrecognized.
Hi, Shelley.
Hello.
Hi. Hiya. So obviously there's this nature versus nurture. So with Matthew, I mean, Isabel knew that she'd had this blood rage. And
No, Isabel doesn't have blood rage.
so,
She knew
so
her
it,
father
well,
did.
she had the genetics for
Yes.
it. So she
Okay, go ahead.
she kind of really nurtured him, I think a bit more than his sister, who was cuckoo, is a nice way of putting it, kind of with the blood rage. I'm wondering, with the blood rage, would nurture help? Like with Diana kind of controls it, and with you're saying with epigenetics, and the next generation after, with Rebecca and Philippe, with Philip, their children, will that have do you think will it have an effect for the grandchildren with the blood rage if it's epigenetic?
I think the nurture piece for blood rage in particular comes into play with the management of it. I do not believe it comes into play necessarily with the inheritance of it. So for example, you're talking about Louisa versus Matthew. We don't know when the two of them were made relative to each other. We also need to think about how old Isabeau is. They didn't have any idea what genetics are. I mean, that's back in the day when we thought, babies came fully formed out of the mud. So I don't know that it necessarily would be that she would think to look for it. I think she just knew she didn't have it compared to a lot of her siblings and her sire. So yeah, to the managing the symptoms, I think, right or wrong, when Philippe recognized the signs in Matthew, he gave Matthew a job and a focus that helped him channel it better. And that more than anything else may have, that combined with Matthew's Catholic guilt may have helped him manage it better than Louisa. Okay, Alex.
Hi, Shelley.
Hello, Alex.
So you mentioned environmental risks. We also know that there's intergenerational trauma, so what we would call potentially adverse childhood experiences. Could that have perhaps impacted, considering what Jack went through as a child?
Yes, absolutely. I think that not only the fact that Jack probably had a lot of demonic sequences, may have been a demon. They didn't know that. He didn't make it that far. But we also know that Jack experienced abuse. I mean, that's in the stories he's relaying to Matthew about his nightmares in Prague. So yeah, I absolutely think that stress and whatever his human upbringing was would further impact his blood rage. So yeah, you have to think about the environmental and the transgenerational trauma across 3 parents, not just 2. So.
Hi, I'm just wondering, based on Philip and Rebecca, the babies, how they both seem to take after individual parents. Like Philip seems to go more towards Diana and Rebecca towards Matthew. Is it too early to speculate if Rebecca might follow the path of having blood rage?
I think at this point in time, it probably is too early to speculate. I mean, we haven't really seen her do anything that we could say is blood rage. Yes, she bites Uncle Baldwin on the finger, but I have a 5-year-old. I've been bitten by that kid before. I mean, not recently, but. Laura had a question. So the mic will come over here, but Laura always gets priority for questions, but she's talking to Adri right now.
Hi, Shelley. Thank you for this fabulous session. I hear doctors talking about the capability of, depending on your lifestyle, to turn on and off genes. When they say that, do they mean literally? Is it really possible that lifestyle
Yes.
will affect epigenetics?
Yes, it is absolutely. So, wow, you guys are taking me to like introbiology lecture. Okay, so in our cells, in almost all of our cells, not all of our cells, but in almost all of our cells, we have every bit of DNA to make another one of us, okay? But we obviously can think about the fact our neurons do very different things in our stomach cells, or our skin cells do very different things from our hormones, thank God. But what we see, that difference comes into play in the genes that are turned on and off in those particular lineages. So if you have a particular lifestyle, and maybe you work out or you run a lot, the cells that are involved in that activity, as they are put under stress and as they grow and they need to turn on and they need to do things, they are going to turn, we say turn genes on and off. Genes aren't ever really on and off. They're going to make the gene produce the appropriate protein to do whatever that gene is supposed to do. So that is what a doctor means when they say turn a gene on and off. You are doing something that is telling your cell, I need you to, you have a big steak. I need you to start producing the enzymes in my stomach that are going to digest this steak. And then I need you to turn those off because when my stomach is empty, I don't want it eating my lining, that kind of thing. So yeah, that's what they mean when they say turn genes on and off. And that's absolutely impactable by your lifestyle.
Hi. I was really curious because the bit where you said, why is this good for us, or why would they have this? Would anything like this, would we assume that it would be good for something? I'm saying this because I'm a Tay-Sachs carrier, right? And Tay-Sachs is a horrible, horrible disease that kills off your children.
Right.
And it's sort of weird for me to think that it might be a good thing in some way. So.
Yes. So Tay-Sachs itself is not, but the gene that is connected to Tay-Sachs and what has happened in what would have happened in individuals such as yourself who were carriers previously absolutely relates to an environmental pressure. And I will apologize that I can't remember what it is for Tay-Sachs, but there are other examples besides sickle cell anemia that show the biogeographical ancestry of a particular ethnic group and the exposures that they had. There's a couple of thalassias that are connected to like typhoid exposure in the Mediterranean. So it all relates back to what your ancestors experienced directly and the reason why any copy of that persists across the generations. And it just, the thing that we have to remember is genetics and environmental pressures work on a very, very different time scale. So we can absolutely say right now, okay, our immune systems don't need to be as active as they were because we're sanitary now, we have clean water, we have clean food, so they should just shut off. Well, they don't just shut off. They get bored, and that's how you get allergies, actually. So there's a lot of evidence that allergies are connected to overactive immune systems because they don't have anything else to do. It's like when demons get, so getting dirty, yes, absolutely. So that was just a comment. Does that mean get dirty? Yes, it does. There's a lot of evidence. If you let your kid eat that dirt when they're growing up, they are not going to have the same kind of allergies. So, yes. Now, did you have a question other than about getting dirty? No.
So, on NPR recently, I heard that they're doing a CRISPR trial.
Yes, CRISPRs, yes.
For sickle cell anemia.
Yep. Yes, I will absolutely. Okay, I will repeat the question and I'll offer a little background when you did. So there was recently an episode on NPR that was discussing CRISPR. CRISPR is a technology for doing genetic modifications in a genome. And they're turning out to be really, really precise. It's really going to be the current game changer of what we can do with biotechnology. It's going to be on the scale of when we even figured out that DNA is a genetic material. There have been some CRISPR studies that have garnered attention and haven't necessarily followed through, but there's currently an effort to look at modifying, for example, the sickle cell anemia gene and removing it. The ultimate question was, would that work for blood rage? I don't know that that would work for blood rage because it's not a single gene disorder. And so you would need to figure out all of the regulatory sequences associated with all of the appropriate gene regions on the creature chromosome. And then you would have to be certain that those regulatory regions aren't working on other genes, so I think it would be a little bit too big of a cascade.
A general sort of genetic question. A condition, for example, like Duchenne muscular dystrophy, where the female tends to be the carrier and only affects male offspring. Is that something that would ever sort of spontaneously occur in a woman's genetic blueprint, or is it something that you would need to trace back generationally, or is there an element of spontaneity with that sort of
There's
mutation?
always going to be an element of spontaneity, and that's in anything. So we can say, Huntington's is due to these number of repeats, but there is not something that would say there would not be an atypical Huntington's patient who has a completely different mutation, or it's due to something other than the CAG repeat. So yes, there are absolutely always spontaneous mutations going on. The thing, people hear the word mutation, and most individuals have one of two responses. One is mutations are bad. They cause things like Huntington's, or they're connected to breast cancer. Or if you're contemporary with some of us, you think, ooh, mutations, that's how you get X-Men. Yeah. The truth is wide and in between and none of those things. And that is, there is, in fact, a constant rate of mutation going on in DNA. There are mutations that can cause a beneficial impact. There are mutations that can cause a negative impact. And the vast majority of them have no impact, either because they're not in a gene or they are in regions of the DNA that truly don't have a function. So all of that is a long-winded way of saying statistically, yes, you can always have a random mutation giving rise to any type of disorder, including what could then become an inherited disorder, even sex-linked.
Hi. Going back to New Orleans.
Wave, okay,
right
so
here.
I can look at you.
Could you maybe speculate on both the environmental and the genetic combination for Marcus going wild? Was it, what would it have been, maybe environmental or social, that would have triggered Marcus to behave like he did in New Orleans?
I think, again, I think Ed summed it up very well. I think Marcus was just being immature. I mean, Marcus was sowing his wild oats. But Marcus was sowing his wild oats without having any understanding of the ramifications of what he was potentially doing. I mean, that comes up when he finds out that Matthew, like, you never told me this. Oh my God, I passed this on. I am therefore responsible for the death of my children, not you who actually cut their throats. So yeah, I think it was just Marcus being, wild Marcus. He's been under his, he was under family management. He sneaks off by himself. We've all done things in New Orleans we don't want to talk about. In the middle?
Dr. Carter?
Yes, wave big. Top left, other left, yes. Okay, thank you.
When you were talking about the generational
Yes.
trauma involved, we know probably that Isabeau's creator qualified as batshit crazy.
Yeah.
We come down through the lines, Benjamin, on down to Jack. Is it a cumulative effect?
It could very well be.
So by the time it rolls downhill to poor Jack,
Yeah, it could very well be. But it could very well be that. But the flip side of that is it has passed the point of being advantageous, because we know Jack is the one that cannot make offspring. Jack is the vampire killer. Sorry, that's a big spoiler if you've only watched the TV, or you haven't gotten that far in the Book of Life. Jack is the vampire killer. Everyone he bites, or not everyone, most of them do not survive.
You had mentioned that stress can aggravate blood rage. Now with Isabeau, she didn't have the blood rage, but she's a carrier. With the stress that she was under when she was tortured by her maker, that wouldn't set off blood rage because she's a carrier?
I think that goes to it probably being a mixture of all these things. So she didn't have enough of the markers to be predisposed, if you will. She's kind of in this, she's in this area right around here. So she doesn't have enough of the markers to manifest it herself. Therefore, the stress is not going to do anything to her. I mean, these, for example, if it was like Huntington's, the number of repeats is set unless you have a spontaneous mutation to increase your repeats. I'm going to get your question. No, wait, well, we're trying to record, so you got to have the mic.
Okay, in your opinion, Shelley, the future of genetics, do you think it's going to make us perfect humans, or are we always going to have bored genes that go haywire?
It's always going to be situationally dependent. I mean, think about what's going on in our environment right now, in our world right now. What helps us right now will probably not help us 50 years from now. I think humans are in a unique situation of being able to modify their genetics, but going back to CRISPR, right now we can't use CRISPR in humans because it has too many off-target effects. You're trying to fix one thing, you're going to muck up 5 others. That's what we've seen in almost all previous genetic modification gene therapy trials. There was, I forget what the disorder is for the classic case that, I mean, they tried genetic modification in humans back in the 80s. They corrected the disorder. They gave half of those patients leukemia as a result. I mean, that was an unintended consequence. So I think there's too much of that for us to ever, design the ideal offspring. But then also think about, we're not really in control. We decide aesthetically what we find pleasing. Maybe we all decide, maybe in future generations they decide everyone should have brown eyes. There's a good environmental reason why you need light-colored eyes. It relates to the same reasons why you might need light-colored skin. So I think the more we try to muck around, the more Mother Nature's going to bite us in the butt over it, quite frankly.
To follow what you said about Jack and the idea that blood rage is beneficial, because we know it's beneficial to sort of perpetuate, because then mixed with Weavers, you get more children. So if you look at Jack's situation where he's the vampire killer, in that situation, it's almost like the disease is killing itself out.
Yes.
It doesn't want to multiply anymore. Like
Yes.
there are enough vampires with blood rage around.
Yes,
right
so there are actual cases like that. Ebola. Okay, so we don't actually know what the environmental host of Ebola is. All we know is when it hits humans, it kills the host too quickly. Okay, Ebola will, once it infects and an individual has Ebola, they die very, very quickly. If it were not for modern transplanet travel, Ebola would not be the concern it is now, because it is possible for you to travel from Africa anywhere around the world in a short amount of time than the virus will kill you. Previously, that wasn't the case. But we do know that humans aren't the environmental reservoir for Ebola because it kills us too quickly.
Sorry, guys. Adri said this is the last question.
Do you think there could be a correlation between blood rage and the so-called murder gene that they've looked into, making criminals more violent who happen to have that gene? I mean, it may not be related to this, but it was just something I thought of.
So this is going to date me and a couple of other people in the room. For a while, there was this theory going around about the Superman syndrome. Have you ever heard of this? Or if you've ever watched Aliens 3, there was the Superman criminal planet. That was the idea that if you had extra Y chromosomes, you're really more aggressive. You're going to be things like a serial killer. That didn't actually hold true when they started looking at the population. The thing to keep in mind, and I think the murder gene is like that, correlation is not the same thing as causation. So if you are looking at a population that has already restricted itself for some reason, so you are looking at a population of murderers who are murderers for perhaps different reasons, you make your haystack smaller, so it's easier to find a pen.
Okay, thank you.